In this example, we have the graph of a polynomial y equals x cubed plus 2x squared minus 5x minus 6. Zoomed in on its one solution, x is equal to 2. Now, we're probably right to assume that that's not the only solution. If you think about the end behavior of this polynomial, we would expect the end behavior of this polynomial to look something like this on the two ends. We have a left end pointing down and a right end pointing up. The likelihood that this is it and then it's just sort of traveling between those 2 points is pretty low. Also, the fact that this is a cube is probably a pretty good indication that we should have somewhere in the neighborhood of 3 solutions. Sometimes we don't, but that's a pretty good first guess in terms of the number of solutions. So we should be assuming that there's 3 solutions, and we should be assuming a different look to the end behavior beyond what we can just see here. And that's what's going to end up happening. That all being said, let's think about how we could break this down and figure out some of our other solutions. If we can identify that x is equal to 2 is a solution to this polynomial, the remainder theorem and its consequences guarantee us the fact that x minus 2 will not have a remainder. That means that it is a factor of that original polynomial. Now, diving right into a factorization of x cubed plus 2x squared minus 5x minus 6 might be a little bit tricky. But if we know that this binomial is a factorization or part of the factorization of that binomial or of that polynomial, we can do a little bit of synthetic division to break the polynomial down first and then look to see if we can find any future factorizations from there. So utilizing some synthetic division, we're going to go with our number 2 on the outside and then our coefficients, 1, 2, -5, -6. As always, we'll bring down our first number in the synthetic division. Then we multiply and we add. Then we multiply and then we add. And then we multiply and then we add, leaving us with a 0 remainder, which is exactly what we anticipated. So rewriting this polynomial here, we get that x cubed plus 2x squared minus 5x minus 6 is equal to our divisor factor of x minus 2 and our leftover quotient polynomial that we get from down here, x squared plus 4x plus 3. You should have clocked pretty quickly that that polynomial, that trinomial quotient, can factor pretty easily into x plus 1 and x plus 3, giving us 3 solutions of x is equal to 2, -1, and -3. So the anticipation would be is if I cleared out all of this writing and backed out of the graph, I should expect to see a solution at -1 and -3, thanks to the factorization that we were able to do from the synthetic division and the remainder theorem contribution. So let's clear out some of this writing, and let's back out a little bit, and there's my 2 solutions. So we have our solution here at -1, just as we suspected, and our solution at -3 to be grouped with our solution at 2. Synthetic division opened the door knowing one of the answers, knowing one of those solutions. We knew 2 was a solution. That means x minus 2 has to be a factor, and then we take our work from there. There will be occasions when we're not able to factor beyond just the one factor, and that's okay. We would have just the one solution. But in this case, we were able to. But we want to give ourselves the opportunity to check for all of the solutions, and synthetic division / the remainder theorem gives us another option with that.